Hello, my name is Sritisha and welcome to our channel Coding with JS. We will learn arithmetic operators and how JavaScript handles math operations.
Arithmetic looks like the least surprising topic in programming. Addition, subtraction, multiplication, and division from school. And for the most part, that intuition serves you perfectly. But 2 of the 7 operators behave unlike other languages. And one famous example makes people think maths is broken. So we will cover all 7 and then explain that example. Let us start with the 3 that hold no surprises at all. Addition works exactly the way you would expect it to. 7 plus 2 gives 9 with no complications. Though remember, it also joins strings from the coercion video. Subtraction is completely unambiguous by comparison. It has only one meaning, so it always converts to numbers. Multiplication behaves identically in that respect. Both operands become numbers and then get multiplied. There is also a unary minus, which negates a single value. We will cover the unary operators properly in a later video. Now we reach the first genuine difference from other languages. We divide 7 by 2, which are both whole numbers. In Java or C, that would give you 3. Because integer division there throws away the remainder. But JavaScript gives you 3.5 instead. Division here always produces a floating point result. The reason is that JavaScript has only one number type. There is no separate integer type to divide into. Every number is a float underneath, as we saw in the types video. So integer division simply does not exist as a concept. If you actually want a whole number, you must round it. Math.trunc chops off the decimal part cleanly. Math.floor also works but behaves differently for negatives. Truncation goes towards 0, while floor goes downwards always. For negative numbers, those two disagree, so choose carefully. The next operator is the one beginners use least. The percent sign is the remainder operator. It answers what is left over after dividing evenly. 2 goes into 7 3 times, leaving 1 behind. So 7 remainder 2 gives us 1. This operator is far more useful than it first appears. The most common use is testing whether a number is even. Any even number has a remainder of 0 when divided by 2. So a single comparison tells you even or odd instantly. It is also how you wrap a value around a range. Cycling through colors or positions on a grid uses it constantly. And it converts seconds into minutes and leftover seconds. There is one behavior of it that surprises people. Here we take the remainder of -7 and 2. Many people expect 1 because the leftover feels positive. But JavaScript returns -1 instead. The sign of the result follows the left-hand operand. That makes this a remainder operator, not a true modulo. A real modulo would always return a positive result. Most languages made the same choice, so it is consistent. But it bites when cycling backwards through an array. The 7th operator is the newest of the group. 2 asterisks together mean raised to the power of. So 7 to the power of 2 gives 49. Before this existed, you had to call math.pow. The operator form is considerably easier to read. But it has one property that catches people out. Look at this expression with 2 exponent operators. Most operators group from the left, so you might expect 64. That would be 2 to the third, then squared. But exponentiation groups from the right instead. So it calculates 3 squared first, giving 9. Then 2 to the power of 9, which is 512. That matches how mathematicians write stacked exponents. It is correct, but use brackets to make it obvious. Now for the example everyone has seen screenshots of. We add 0.1 to 0.2. Every human knows the answer is 0.3. JavaScript prints 0.3 followed by a tiny error. People post this as proof that the language is broken. It is not a JavaScript bug at all. Python, Java, C, and Ruby all produce the same result. It comes from how computers store decimal numbers in binary. Here is the clearest way to understand it. Try writing 1/3 exactly in ordinary decimal notation. You get 0.333, repeating forever. You must stop somewhere, so you store an approximation. Binary has exactly the same problem with 1/10. 1/10 in binary repeats forever, just like 1/3 does. So the stored value is very slightly larger than 1/10. The same is true for 2/10 with its own tiny error. Add those two approximations and the errors combine. The sum lands very slightly above 3/10. And that difference is just large enough to be printed. So the arithmetic was perfect, the storage was approximate. This has one very important practical consequence. Never compare two decimal results with 3 equal signs. 0.1 plus 0.2 does not equal 0.3. Instead, check whether the difference is tiny enough. Number.epsilon gives you the smallest meaningful difference. Take the absolute difference and compare against that. And as we said last video, keep money in whole cents. Integers have no precision problem whatsoever. So let us gather all 7 operators together. Plus, minus, and multiply behave exactly as expected. Division always gives a float because there is one number type. Percent is remainder and its sign follows the left operand. Double asterisk is exponent and it groups from the right. And decimal